All right, welcome back to statistics. We are talking about expected value and standard deviations and probability in general, probability distributions. Okay, so let me go ahead and share screen with you. And let's go ahead and look at a couple of problems and see how far we can get. All right, so this problem, okay, we have X represents the number of tires with low air pressure on a randomly chosen car. So it could have zero tires with low air pressure, or all the tires could have low air pressure. Okay, so we're talking about the number of tires here. Makes sense that we're going to go from 1 to 4. Okay, and now we have our X and our P of X. Okay, now I know it's coming, so I usually like to write these problems vertically rather than horizontally, but there's nothing wrong with writing them vertically, or horizontally rather. Okay, so I'm just going to go ahead and draw these out, and we have 0.2, okay, 0.1, 0.3, 0.2, and 0.2. So why do I add the extra 0? Because it's easier for me to think about this as change than it is for me to think about them as numbers. Okay, so let's have a look. So what's P of 2? So they just really, it's like a warm-up exercise. All they want us to do is like, what's the probability when X is 2? It's a comprehension problem. So this was just 0.3, and that's it. Okay, that's all they wanted. So there's a problem. Hold on, we're going to pause so we can go back and do this. All right, so there we go. I just had to restart the program here. I don't know how you guys do some of this stuff, because it seems to go down much faster than I would have liked. So we have to change a little bit because, of course, they dealt me a slightly different problem, but that's not a big deal. So we're not started yet, so it's 0.30. Okay, 0.1, 0.2, 0.2, 0.2. All right, so these are all 0.2s, except for, okay, there we go. So in this case, right, what are they asking me? They're saying, what's P of 3? Okay, so they just want, okay, what's the probability under the 3 here? Don't overthink it. Okay, they really just want to know, can you read the chart? Okay, that's all they're asking. Okay, now greater than or equal to 0. Well, that would be all of it, wouldn't it? Like that would be the whole thing. So 1. Okay, like what about 5? Like those would be zeros. They're not defined. So greater than or equal to 0 would be all of it. So we have 2, 4, 6, 70 cents, 70 cents, and 30 cents is $1. So there we go. Okay, probability that all 4 tires have low air pressure. And again, all they're doing is like, did you understand the chart? So don't ever think that. It's all they want to know. Okay, I know these are there's a little bit easier on the side here. The probability that no tires have air pressure, right? Probability X equals 0 is 0.3. Okay, so again, so the last problem was easy. It was harder than this one. Now we get to the mean. Okay, so this is the expected value. Okay, so you have to remember that mean, right, mu is equal to E of X. Okay, and remember that this was the sum of X times P of X. Okay, this is a formula that bears remembering. You probably want to remember this one. Okay, but if you draw it this way, right, we're just going to multiply the first 2 columns together and add that up. Okay, that's all we're doing here. So X times P of X here, 0 times 0.3. Okay, I can do that one. 1 dime is 0.10. 2 times 20 cents, right, that's 40 cents. 3 times 20 cents is 60 cents, and 4 times 20 cents is 80 cents. Okay, now we just have to add that up, right? Here's $1, here's $1.80, here's $1.90. All right, so we just get the tens together, right? That's 60 cents and 40 cents would be $1, $1.80, $1.90. Right, so that's all we're doing with that. Okay, so that's our average. Okay, that was our 1.9. 1.9. Okay, probabilities have to add up to 1. Expected values do not. Okay, now they're going to make us do a standard deviation. Okay, so let's go ahead and run this again, okay, by hand, and then again I'll show you how to do it in the calculator. Okay, I don't know what's going on with this, but whatever. All right. Oh no, weird lag. Okay, what's my x squared? Okay, what is my x squared? I have to restart this thing. Okay, I don't like that. So 0 times that, that's going to be 0. Oh wait, we're just calculating x squared, sorry. So 0, x squared, right? When x is 0, that's going to be 0. Then we're going to have we're going to have 1, because 1 squared, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Now it seems to be working pretty well again. Okay, now x squared times p of x. Okay, so we're just going to multiply this p1 times this x squared. So that's going to be 0. 1 times 0.1 is 0.1. 4 times 0.2, right, that's 80 cents. 9 times 0.2, right, 9 times 2 is 18. So that's $1.80. And then 16 times 0.2, that's going to be $3.20. Okay, so I'll go ahead and do that. Okay, we're going to add these up. Oh, this is going to be harder. So $3.20 and $1.80. What is that going to do for us? It's going to be 0.1. That's going to be $5, right? And then we have $5.90. So it's $5.90. That's not the answer. This was e of x squared. Okay. And remember, standard deviation, right, is the square root of e x squared minus e of x squared. All right. So we have this piece. This was $5.90 minus, what is this? This is 1.90, right? That's our average. That's what we found out for the mean. We have to square this. And then we're going to go ahead and take the square root. All right, so this is 590 minus 3.61. You have to subtract them. Okay, so what is that going to be? That's going to be 8. That's going to be 1. So 10 minus 1 is 9. 8 minus 6 is 2. 5 minus 3 is 2. 229. That is not a square root that I know. So let's go ahead and get to our calculator. Give me a moment. I'm going to pause this and grab my calculator. Okay, got this thing here. So all we're going to do is we're going to take these square roots. So the second function squared. Okay, so we get our square root to come up. 2.29 equals. Notice I didn't need the closing parentheses for that one. Now, what are they going to want us to do for how many decimals? They want 3 decimals, so fine. It's 1.513. 1.513, that's our answer. There's no rounding going on, so this is 1.513. All right, check that. Looks pretty good. Okay, so that is how you get your, again, there's another formula that's in the book. If you want to use that, that's fine. We'll go ahead and we'll hit our stat. I want to make sure I can edit some lists. And if you just don't want to deal with the by hand part, oops. If you just don't want to deal with the by hand part, we could just do it this way. Okay, so in the first one, we're just going to have what the x's are. So that's 0, 1, 2, 3, 4. Okay, and in list 2, all we're going to do, okay, is type in. We're going to have 0.3, 0.1, 0.2, 0.2, 0.2. And now when we go ahead and do our, our statistics, we want to do our one variable statistics. We got to tell it that, well, you want to do the numbers in list 1, but you want the weights, you want the probabilities in list 2. Okay, weights being like how important they are. This is 3 times more important than this one. Okay, calculator will do that for us. Now look at that, 1.513. Okay, our average, right, 1.9, same thing that we got. All right. So it's okay to use the calculator for this. Like I said, I'm never going to ask you this question on a quiz. And even if I did, right, you guys have calculators available to you. So it's okay to do it with the calculator. I'm just used to doing this problem by hand, just from ages upon ages of doing it this way. But also, like, if you do it by hand, like you know what you're doing here. Like if you ever had to do this again, you could do it. Okay, if you ever have to take a class where it's like, no, we have to do this by hand. Like, why? But you've got this. All right. I think we're okay with problem number 5. I think we'll be okay with that. Okay. All right. Great. Okay, so this is a bigger problem. So we have a number of days. Okay, so 500 days. How many days would they wait to seek medical treatment if they were suffering from pain that interfered with their ability to work? Okay, here are the results. So what we're going to do here is we're going to take each of these frequencies and we're going to divide it by the total. Okay, so what we're going to do is I'm going to make a little chart. Okay, number of days. Okay, so we have 0, 1, 2, 3, 4, and 5. All right, and then our frequency, right, it's going to be 29. But you know what? I'm going to do it a little bit faster here. We're going to say frequency divided by total. So this column is going to be 29 divided by 825. This column is going to be 437 over 825. This column is going to be 265 over 825. Let's make that a 5. Okay, 71 over 825, 15, 825, and then 8 over 825. Okay, so these all added up to 825. That's why I'm dividing by them. Okay, this is going, all of these numbers are going to look like probabilities. They're all positive. They're all between 0 and 1. And they're all going to add up to what? They're going to add up to 825 over 825. They're going to add up to 1. Okay. So there we go. Let's see. Let's do the number of days. Construct the round to 3 decimal places. That's what I was looking for, was round to 3 decimal places. Okay. So what we're going to do, 29 divided by 825. Okay, we're just going to write this down, 0.035. Okay, this is 0.035. Okay, next one, 437 divided by 825. 0.5296, that's going to be 0.530, isn't it? So that's a 0.530, rounding to where we have to round, right? This 6 is going to turn this 9 into a 10, which is going to turn that into a 3. Okay, so we have 265 divided by 825. All right, that's 0.321. Okay, that was kind of nice. All right. And the next one is going to be 71 divided by 825. Saying is about 0.086 here. 1, 2, 3 decimal places. We don't have to worry about the 0 here, so it's just 3 decimal places. Then we have 15 divided by 825. Okay, 0.0181. So we're just going to stop at the 0.18. So this is 0.018. And then we have 8 foolish people that won't see a doctor until a whole week of them not being able to work correctly. Okay, so here we have a little bit of an issue, right? 0.0096. The 6 is going to round this to a 1, so we're going to get 0.010. All Now we could check to make sure these add up to 1. If they add up to 0.999 or 1.001 or something, we're fine. Okay. So let's see if we have this. Let's go with 35 plus 530, 530 plus 321. Oops. Oh, I hit enter. Sorry. It's 35 plus 530 plus 321 plus 86. Oops. Oh, plus 18 plus 10. Great. Got 1,000. Okay. I just didn't write in the decimal places. Okay. So this is 35 things. This is 530 things. All right. So we just didn't deal with the decimal places because we're not trying to do a calculation here. I'm just checking to make sure, like, did these add up to 1? Did I do it correctly? Yeah, we're okay. All right. So there's our piece there, because we're going to type these in here. And I'm sure you have experienced the wonderful side of Connect Math where it is very picky. Okay, so I just want to make sure I only have to type it in once, because who wants to have to do this more than one time? Let's say 0. Okay, so this was 0.086. 0.018 and 0.0. Still not going to promise it's going to be 100% right, but there we go. Okay, what is the probability that a person will wait for 1 day? All they want you to do is read this off the chart. Okay, so I'm sorry, it's going to feel a little on the weak side, but they're just checking. Do you know how to read this table once we've created it? That's all we want to do. Okay, wait more than 4 days. Okay, so would wait for more than 4 days. Is 4 more than 4 days? I'd say no. So how many people are going to wait 5 or more days? Okay, and that was 0.010. All right. Okay, fine. Compute the mean, round to 2 decimal places. What do you want to bet that part 5 is going to be compute the standard deviation? Okay, of course it is. So we already have our table started here. Okay. What is our x times p of x? Okay. The reason I do it this way is because I kind of like to see what's happening, and it's easier to change. Like if I messed up something, it's easier to see that and make it a fix to it. Okay, but what we're going to do is we're going to say 0 times 0.035. That's 0. 1 times 0.530. 2 times 0.321. Isn't this going to be 0.642? 3 times 86. 3 times 0.086. I don't know. 0.086. 0.258 sounds good. Okay, 4 times 18. 4 times 0.018. That's what we have here. Okay, 72. And then 5 times 5 times 1 penny. Right, and this was 0.50. All right, now we got to add these up. Okay, so this was 0.350 plus 0.6. Actually, how about we just do it this way? How about we say 530 plus 642? Just remember that we didn't take the decimal. Plus 258 plus 72 plus 5. Notice the 5 is in the same column as the 72, the 2 for the 72, the 8 for the 258. So we could add these like they're pennies. right? Or tenths of pennies, rather than have to do all the decimal places. Okay. We got 1507. Where's the decimal place? We pretty much removed 3 decimals, right? So we put the decimal here. When we added them up, we got to put it back. 1, 2, 3. Okay, so 1.507. That's our mean. Right? 1.507. Is there a check answer? There is. I didn't like that. What did we not do? Let's double check. So 0 times that is 0. We have, let's be more careful. Maybe I've screwed up the decimal places. That's entirely possible. 0.530 plus 2 times 0.321 plus 3 times 0.086, right? Plus 4 times 0.072, all right? And then 5 times 0.010. Oh, that's not right. It's 4 times 0.118. Okay. 4 times 0.018. There we go, 0.72. 5 times pennies, 0.05. That should be okay. 3 times 0.321. It's the only one I don't think I. Oh, it's not right either. What am I doing? 3 times 0.086. 0.258. 2 times 321. 642. All right, let's just be careful about adding these up then. So we have 0.350 plus 0.642 plus 0.258 plus 0.072 plus 0.050. I bet that's it right there. 1.552. All right, so let's just go back to here. Okay. So I tried to be cute, add things up a little bit faster, and look where it got me. It got me to spend more time adding this up. All right, there we go. So I shouldn't take the shortcut. Sorry. All right, now we're going to calculate standard. We're going to calculate standard deviation. Okay. So remember, this is going to be x squared times p of x. And what we're going to want to do is we're going to say e of x squared minus e of x squared. That's going to give me the square standard deviation. We still have to take the square root. All right, so it's going to be the square root of e of x squared minus e of x squared, and then we're taking the square root of all of that. Okay, so what's my x squared? 0. 1 squared is going to be 1. 2 squared is going to be 4. 3 squared is going to be 9. 4 squared will be 16. 5 squared will be 25. All right, there's my x squared. Now, when I multiply x squared times p of x, all right, here's my p of x here. We're going to grab the stuff in column 2 times the stuff 1, 2, 3, column 3 times the stuff in column 5. Right? So this one times this one. Okay, column 3 times column 5. Okay, so 0 times that is going to be 0. 1 times 0.530. Okay, 4 times, I'm not even going to pretend to be good at this one, so 4 times 0.321, okay, 1.284, okay, 1.284. Okay, so we have 9 times 0.086, 0.086, 0.774. Okay. And then what do we have? We have 16 times 0.018, 0.288. Okay, and finally we have 25 times 0.01. I should need a calculator for that. And now we got to add these up. All right, so this is going to be, this is e of x. This was e of x squared, and this was not e of x. This was, it was 0.1, it was 1.552. Okay, let's fix that. All right, so this e of x squared, we're just going to add these pieces up. All right, so here we go. 0.530 plus 1.284 plus 0.774 plus 0.288 plus 0.25 equals 3.126. All right, now our formula is to take the square root e of x squared minus e of x squared, and that should be good. Okay, so 3.126 minus 1.552 squared. What's that? Okay, so minus 1.552, and hit the squared button here. By the way, if you ever get a negative number on this, you screwed up. Okay, something you've done went terribly, terribly wrong, because it can't be a negative. This can't be negative. 1.717. Okay, and the next thing we're going to do, second function square root, second function answer, so I don't have to type this number in again. It's just right here. Equals, and I'm kind of hoping that my round off and the publisher's round off agree. So this is 8469, so it's going to be 0.847. So I'm kind of just hoping that they rounded off in the same place that I rounded off. Fingers crossed. All right, so this was 0.847. Okay, and that's going to be our standard deviation, assuming this works out. Hey, it worked out. Okay, so there we go. So I know that one's a little bit longer. Mostly we are dealing with the fact that we have to make our own probability distribution here. That's why it was longer. But and it's a little bit bigger, no problem. Like the last ones, I think, like the tire one is good, it's 5. This one's 6. It takes a little bit longer because of all the calculations we got to do. So I'm not interested in all of that. All right. Expected value. These can be kind of tough. All right, they're a little tricky. There's a couple of different ways you can do them. So if you didn't do it exactly the same way I did it, but you got the same answer, that's probably fine. Okay, so there's different ways we go. Okay, so again, we're doing expected value. Okay, the sum, we have the value of the event times the probability of the event. All right. So the hardest thing here is turning these words into this equation. So in New York State Lottery number, okay, you pay $1 and bet that you can get the sum of the numbers to come up to 13. Probability of winning is 0.06. Great. If you win $5.50. profit of $4.50. If you lose $1. They don't come after you for more. Okay, so let's go ahead and write down our, they were very nice to us in this case. If we win, what do we win? We win $4.50, right? Because we spent $1 to get the ticket. How often does this happen? It happens 0.06 amount of the time. Okay, so this is a win. What happens if we lose? Well, we spent $1. Okay, how often is this going to happen? 0.94 times. Right? So notice these add up to 1. You either win or you don't. So what we're going to do, right? This is the probability. So we're going to multiply these across. Okay, so this is x times p of x. So what is 450 times 6%? 4.50 times 0.06. Okay, so this is 0.27. And in this one, this is just going to be negative 0.94. Right? 1 times 0.94 is 0.94. Okay, so we're going to subtract 0.94 here. All right. So on average, playing this game, like 1,000 people played this game, they would all lose, you know, the average among all of them, okay, is they're losing 67 cents. Now, nobody's losing 67 cents. You're either losing $1 or you're making 450. But if I put this over a large number, this was what I would multiply by the number who played, so I could figure out like what's going on. Now, to the state, they're making 67 cents per person playing this game. Okay, and again, nobody is making or losing 67 cents. They're losing $1 or they're getting 450. So this is like in the aggregate what's going on. Okay, you can think about it as this game means you lose 67 cents, but you have to keep in the back of your mind like everybody's losing $1. Okay, some people aren't. Some people are winning 550, but you've already got the $1. Right? So it's hard to, you know, people kind of make shortcuts with this, and it's okay to make the shortcut, but you have to remember what you're looking at when you're doing this. Okay. So is it an expected gain or expected loss? It is an expected loss, right? Oh, is it to the state? Nope, we're still talking about this to the point of view of people, right? Because of the state, it's a gain of 67 cents per person. So, you know, it's a loss, right? So that's how you handle an expected value. These can be confusing and they can be tricky because English is a crummy language. All right. So if you're looking at these and you're like, I didn't quite get it, you are not alone. A lot of people, when they come to these problems, have a very difficult time setting them up and figuring out the correct thing. Okay. If you're not in that group, congratulations, you're going to have an easier time of it. But if you're like, these are a little confusing, you are not alone. Okay, that's normal, and with practice they get a little better. Okay, but sometimes it takes a lot of practice to get better. All right, so let's see. We're trying to answer a multiple choice test on a standardized test. There are 3 choices. If you get an answer right, you get 1 point. If you get it wrong, you lose a half a point. And if you assume that we have no ideas, oh, they don't have a choice where you just don't answer it. So if you don't answer it, I guess it's wrong. Okay, assuming you have no idea what the right answer is, so you're just going to pick at random. Okay, so the test might as well be in Latin. Okay, you're just throwing a dart at the answer. All right, so we're going to write down, right? If we get it right, we get the test correct, test question correct. What are we ending up with, right? If we get it right, you get 1 point. So our gain here is +1. Okay, what's the probability that we get it right? Well, there's 3 questions, or 3 answers rather, right? There's 3 answers, and we're just guessing. So this is 1/3. if we get the answer wrong, right, what do we get? Well, it says we lose half a point. So that's -1/2, right? We're losing that much. We're not losing the whole point. We're just losing half a point. Okay. What's the probability that that's going to happen? 2/3. Okay. So our expected value of the event times the probability, x times p of x here, okay, 1 times 1/3 is 1/3. 1/2 times 2/3, right? So this is -1/2 times 2/3. What is that? That's -1/3. Okay, so if we add these up now, our expected value is 0. That's what's called a fair game. All right. So when the expected outcome is 0, that's a fair game because the odds and the reward for you winning balances out the odds and the penalty for losing. Okay, so this is a 0. So that's great. So no matter how many choices you get for people to like randomly guess, our outcome is going to be 0. Okay. So expected points you get 0. All right. Oh, that's all they wanted. Okay. They usually don't ask you for standard deviation on this. All right. Next one. An investor is considering an investment in a startup company. She estimates that the probability is 0.39, right? 39% of a $24,600 loss. Probability of 21% of $10,200 profit, and 13% of a $57,000 profit. And the probability of breaking even. So we whatever we put in for our money is what we're going to get out. Is 0. Okay. What is the expected value for the profit? Would you advise the investor to make this investment? That's a good question. Okay, I got to study finance when I went to grad school, and we did a lot of stuff like this. So if you're ever wondering, like, I wonder which question he's going to pick for a quiz. Like, I like these, so this would be a good one. Okay, investor is starting a startup company. What's our outcomes? Right. So we start off with we have a chance of getting a loss. It's a -24,600. How likely is that to happen? That's 0.39. Okay. We have a probability of a positive $10,200 profit. Okay, and that was 21%. So that's 0.21. Okay. We have a 13% chance. Okay, make that proper 13 as opposed to what that looks like. We have a 13% chance. All right, of getting a $57,000 profit. Okay. By the way, this is what they do to people to figure out if like how risk tolerant they are. Okay, as we put like investments like this in front of somebody and see which one they would prefer. Generally, people who are risk intolerant have a very low standard deviation on problems like this, right? And then people who are risk independent, they're like they don't care about the risk is, they have a very high standard deviation. Okay, so what is the expected value of the profit? All right, so we have our what is the value of the event? What's the probability it's going to happen? So what we're going to do, x times p of x. All right, I need a calculator for this one too. So what do we have? We have -24,600 times 0.39. You don't need the negative in there, but you do at the end. This is -9594. -9594. All right, next one, we have a 0.21% chance of a $10,200 profit. Okay, 24.42, 21.42. That's correct. Okay, and then a 13% chance of a $57,000 profit. Okay, 7410. And then this would be 0. All right, we have to add that up. All right, so negative 9594 plus 2442, 2142 rather, 2142 plus 7410. And then the 0 we don't need to deal with. But the total investment value here, negative. So I would not recommend anybody took an investment here, because you need at least a 0 to say you're going to break even overall. But even still, what you got done, you still want to ask, like, you know, is this going to keep you up at night? Right? You have a 34% chance of making some money, 39% chance of making no money, losing it, and then a 27% chance of just breaking even. So are you going to be able to sleep? And if the answer no, like for a real person, if you like, I'm not going to be able to sleep and I'm going to be looking at this constantly, it's probably, no matter what the expected value comes out to be, it's probably not a good investment, because your quality of life is going to go way down. So minus 42. Check. And by the way, I should put this somewhere else. So yes, I don't know if you know what a stock is or not, but a lot of times you'll see commodities, or you'll see like a Forex thing. And if you've made money on this, congratulations, that's rare. Commodities and Forex, like what you're doing is like, I want to sell some wheat later. And for the farmers and the people that are like, you know, that actually sell this stuff, like that's a good deal. For the farmer, this is excellent, because you could say, hey, I need to sell this wheat at this price, so the farmer can say, okay, I know what my expected yield is going to be. I know what my expected price is going to be. I can plan for the future. I'm going to know if I'm going to make a profit or not. What am I going to do about this? But the people who buy those, they turn around and sell them to somebody else. Okay, the brokerage usually takes it. And there's two people on either side. Like, is it going to go up? Is it going to go down? Well, you want to, as a casual investor, unless you're studying this, you don't want to do these investments. Okay, commodities, you don't want to, you know, futures, you don't want to do this, because in a stock, you buy a stock of Apple, Apple makes a new iPhone, Apple sells a new iPhone, lots of people get in line, they buy the iPhone, they're happy they got a product, Apple's happy they got some money. As an investor, you're happy, your company made money, everybody's happy. Commodities, somebody's betting that it's going to go down, somebody's betting it's going to go up. One of those people is going to get their, is going to win. The other person is going to lose. There are people that spend all of their time deciding, trying to figure out, is it going to go up, is it going to go down? You are not the person working on this for 24/7. Who do you think is going to win, and who do you think is going to lose? So commodities, stuff like that, you want to stay away from. Stocks are okay, they're still risky, but they're a lot less risky than the commodities. Okay, I'll say that again to other people at some point. All right, life insurance. You're making a bet you're going to die. Life insurance company has to take that bet. Of course, they're going to charge you. So a life insurance company sells a 1-year life insurance policy to an 87-year-old woman. Woman pays a premium of, that means this is what it cost her to buy the life insurance policy, $4,300. If she dies within that year, the company will pay $88,000 to her beneficiary, and nothing if she lives. All right. So, according to the CDC, Probability that an 83-year-old woman will be alive 1 year later is 0.9512. She's got about a 5% chance of being deceased, 95% chance of living throughout the year. What is the profit? Will X be the profit of the insurance company? So we're looking at this, right, the point of view from the insurance company. All right. So the premium is a plus. Okay, so we're going to put an X and we're going to put a probability. Okay. So this lady pays us $4,300. All right. What is the probability that we don't have to pay anything out? This is the probability that she lives, right? So this is 0.95. Okay. 12. So congratulations. You've lost your bet because you bet you were going to die. They bet that you weren't. You won. You're still alive, so you lost your bet. But congratulations, you live to see another year. Happy birthday. All right. If she dies, they have to pay out that amount. Okay. They have to pay out that $88,000 to her beneficiaries. But they already have her $4,300. Okay. And then this is 1 minus 0.9512. So we're going to make another little table here. Okay. Here's our value. We make $4,300, or we lose, okay, 88,000, okay, minus 4,300. Okay, so they have to pay out 83,700. All right. Now the probability that she stays alive, 0.9512. Okay. And the probability that she does not survive the year is 1 minus 0.9512. Okay, 0.0488. Okay. So let's turn this around and see if we can't fill out their little table, because they're trying to help us like what's going to happen here. All right. So this is going to be negative 83700. Negative 83700. Okay, the probability that she's still alive, that is 9512. So 0.9512. And the probability that she won her bet is 0.0488. Okay. Oops, I want 0.0488. Okay. These have to add up to 1. These are going to add up to whatever they add up to. Okay. So let's see here. We'll go ahead and check this. Okay, they wanted a comma. Thanks. All right, that's all that means, right? The answer is correct, but it should be written in a comma. All right, will do. What is the expected value of the profit? Okay, so again, right? And again, this looking at this from the insurance points of view, that's going to change which numbers are positive and negative. Okay, 4,300. Okay, times 0.9512. Okay, and this was 4,090 and 16 cents. All right, and this is negative. Oops, I don't want minus. I just want negative 83700 times 0.0488. All right, and that is negative 408.456. Okay, and then we're going to add. Right, so we have, what am I doing? I want plus, because that's a negative number, so it's already there. So we have 4090.116 and they expect to make $5.60 off of this deal. Okay, so the idea is that they're going to sell, like, 1,083-year-old women health life insurance policies. So on this policy, they would expect to make $5.60 because some of them aren't going to make it, but most of them are. Okay. They still might be overcharging her a little bit, depending. Okay. I don't know what the profit margin is on these kinds of deals. They should be close to zero, though. This isn't too bad. Considering the kinds of numbers, that's not too bad. All right. So what are they going to make? They're going to make $5.60. Can't be zero. They got to make something. Otherwise, they'd never take any of the bets. Okay. They want it in dollars and cents. I'm going to say put the cents in there. All right. So look, that's it. That's our 6.1. If you're having trouble with these later parts with the expected values, that's normal. Practice a little bit more. Pretty much here, you could do this. You could say expected value worksheet. You could type that into your favorite search engine. You're going to get more of these things. Okay. Now, I'm just going to let you know, if you're going to type this into YouTube, expected value, this can be done in calculus. Okay. So in calculus, the symbol for adding is this instead. Okay. And you're going to see fx times px. Okay. It's the same thing that we did, except it's for continuous functions and it's in calculus. You're not required to do this. So if you see this, you just turn that video off and find a different one. This is taught at, I don't know if it's taught at 9th grade, but I know it's taught at 11th grade. I know that it's taught here. I know it's taught in upper level. Okay. And I know it's taught in very much upper level. So you have to find the right level for you. Okay. Somewhere in here. So if you can see the video and they're talking about adding stuff up and they're actually adding stuff up as opposed to this adding up, you're in the right spot. Okay, so just be a little bit careful if you go look at this online. But expected value worksheet, you should be able to find something at one of these levels that gives you some more practice. Okay, so good luck with that. Like I said, there a lot of times it's not the arithmetic, it's the English. Okay, and you are not alone if you're having trouble with some of these. Okay, a lot of people do. Right. So good luck, and I will see you in the next section.